In this final video, we're looking at procedural workflows in Mari, so ways to make texturing faster, more efficient, and less reliant on painting every detail by hand. Procedural workflows allow you to reuse, tweak, and adapt textures on different assets without starting from scratch. There are a few main approaches, so you have the tiled and triplanar nodes that we saw in the last video. So a tiled node repeats the texture across your model's UVs, and a triplanar projection node projects the texture from 3 directions. And then you actually have nodes called procedural nodes. So if you right click in the node graph, go to nodes and then procedural, you can see all the procedural nodes available. So a classic starting point is the cloud node, which we saw in the last video. So it's a soft organic noise that's useful for color breakup or dirt. And what's great about procedural nodes is that they're completely seamless too. Procedurals are also non-destructive, meaning if you come back at a later stage, you can easily make tweaks, unlike non-procedural nodes like the paint node, where your data is baked. Another great procedural node, for example, is the cellular node. It adds a pattern that could work for lizard or dragon scales, and you can tweak the node properties until you find something you like. Procedurals can also be blended together with a merge node to create even more complex results. You can even feed one procedural into another's position input to create more organic textures, such as moss on stone or marble veins, for example. Now let's move on to bake maps. With it, you can create geometry-driven textures procedurally. Some common bake maps are ambient occlusion, which creates a map of the cavities of your mesh. This can be really useful to create dirt or grime. And then you have curvature, which highlights the edges of your mesh, ideal for scratches or dents. Another useful map is the position map. With it, you can limit textures to certain areas of your mesh, like top and bottom or left and right. This is great for adding things like dust or even mud to certain areas like the feet. So how do you create these maps? You can generate them through the bake icon. And once you clicked on it, choose the maps that you need. So ambient occlusion, normal, etc. Then select the meshes used for baking. And if you preview each map, you can even tweak the settings. For example, you can remove unwanted lighting from the ambient occlusion map, so it's purely cavity detail. You can also increase the sample count for higher quality. And then once you're happy, select geochannels and click bake. Then to use the bake maps, you just need to create a geochannel node and choose the bake map from the drop down and plug it into a mask input. So let's say you wanted to add dirt only to the crevices of your dragon. To do this, you can create a dark brown color node for the dirt and then connect it to a merge node and plug the ambient occlusion in the mask channel. You can also add a brightness lookup node to invert the ambient occlusion map or to tweak it further. You can even add extra grit to make it more realistic by adding a procedural node into the mix. Here we're using a cloud node to break up the map to give it a more organic, realistic look. And then lastly, you have smart materials or smart masks. So smart materials are materials that combine procedural nodes, bake maps, all into a reusable setup. So if you create a material node and build a material inside it, you can then promote each node's key sliders to a top level so you can tweak them without opening the material group every time. This is the same for smart mask, except you only have one output, and it's not a material, it's only a mask. Then, if you save your smart material or mask into your library, you can drop it onto any mesh in the future. If you want to learn even more in depth about smart materials and how to create them from start to finish, check out these 2 videos. So that's it, you've completed Mari in minutes. We've covered everything from texture theory to painting, the node graph, and procedural textures.